Three, nothing, 2, 3, 4. 3, nothing, 2, 3, 4. Maximum possible product of any 3 elements. Well, you just always choose the parity that you want. So I guess it would be the largest absolute max value and the largest absolute value, the second largest absolute value. And time to complete all deliveries. Two delivery drones are tasked with completing a specific number of deliveries. Drone I must complete D sub I deliveries. Okay. So we got the number of deliveries for each drone. Both drones require recharging at specific intervals during which they cannot make deliveries. Drone I must recharge every R sub I hours. What? That seems... How did only 2,000 people get this? Each delivery takes exactly 1 hour. And only one drone can make a delivery at any given hour. That sounds weird. So they must complete a certain number of deliveries. Can you simulate it? No. Well, our sub I is that. 3 times 10 to the 4th. That's the recharge interval. Only one drone. Both drones require recharging at specific intervals. Oh, it's not after an interval. Okay. I see. So then it becomes, which drone do you take at hours that are multiples of r sub I? So if you had 2 and 3, like here, you'd probably want to prioritize this because it has to make less this because it has to make more deliveries. So you'd say 1, 2. It must recharge every r sub I hours. Oh, no, it's even easier than that. So this has to recharge at multiples of 2. This has to recharge at multiples of 3. You could binary search it. You could say, can you finish by this time? And then you would do that by saying, how many deliveries can each drone make? If you say, okay, I have 100 units of time to spend. Do I have Minecraft open? Yeah, that's funny. Whoops. Okay. If you have 100 units of time and you're gonna say like these you can't do anything, and then these you can't do anything. Let's say it's like that. And then these overlap for some reason. This could never mathematically happen, but I'll go with it. Or no, let's make it a little more realistic. Let's say that, and then these overlap. You would say, okay, well, how many deliveries do I have to make? I think you just check 3 things. I think you just check, there's exactly one spot where they overlap. So one spot where you cannot make deliveries. So you're gonna make a total of 99 deliveries. From every other spot, something can make a delivery. So you check, you say, okay, there's one thing where neither of them can make deliveries. So this is one constraint. Do I need to make a total of at most 99 deliveries? And then you would also say, 1, 2, 3, 4, 5. There's 5 here, and it looks like 3 here. So like, does this need to make at most 97? And does this need to make at most 95? Because if this can make 95, you just do every single spot that's not. Then there's some way to arrange it where you just don't use these and it works. But then that's not the only constraint. You also need to make sure there's some way to arrange it where these X's can, like, all the deliveries can be made in this time, and that's still enough. But that's still not enough because you could do both of them, but not together. You couldn't do both of them at the same time, and that's where this 99 comes in. There's some way to arrange both of them that works, as long as they don't both add up to greater than 99. So this could be 95, and then the X's could be at most 4, which would mean you could put one here, 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 and here. If this was 96, it wouldn't work because then you'd have to take one of these circles. If this was, let's say, 90, then this could be, you could have at most 9, which would be 1, 2, 3, 4, And then there's 5 left. There's 5 spots here that you didn't choose. Okay. So I'm going to have, what's the threshold? And I want the minimum total time in hours required to complete all deliveries. So I can have it return true if it works, false if it doesn't, and then the earliest time. Let's see. Can they be 0? No. If they both need to make 10 to the 9th deliveries, R sub I could be 2. That doubles both of them. You're only getting up to 4 billion. So the overlap here is going to be, I think, the LCM, right? So like with 2 and 3, the LCM is going to be 6. That makes sense. For something like 6 and 4, the LCM would be 12. That seems fine. So I'll have these be the threshold over R at 0, threshold over R at 1. This is going to be the number of, I'm assuming you're taking exactly the threshold units of time. So if this was 10 and you said one of them had to recharge every 5, then you would be using the 5th and 10th hour to recharge. I think the math just kind of works out. Okay, and then Z is threshold over the LCM of R0 and R1. Let me just get these. Let's check 6 for problem 1, see what that comes up with. So it's saying you have to pause every 2, so you're going to pause at time 2, 4, and 6. This is going to pause at time 3 and 6. This is just going to pause at time 6. That seems right. Let's try 5. This is to pause twice. This has to pause once. There's never a time where both of them have to pause. That seems right. So then the math is pretty simple. It's just how many, I have to check 3 different things. So if D at 0 is greater than threshold minus X, then it doesn't work. If D at 1 is greater than threshold minus Y, it doesn't work. If D at 0 plus D at 1 is greater than threshold minus Z, it also doesn't work. Four, 6, 2, slightly off. It's off by exactly 1. Interesting. No, that's not interesting. This is just off by 1 because this is offset. It's saying what's the index in this range, but because the range started at 1, the index is always going to be 1 less than the actual value. It's like a random little detail. We got 5, 7, 3. Looks good to me. Lexicographically smallest permutation greater than target. Oh, these are so annoying. The lexicographically small string is both a palindromic permutation of S and strictly greater than the target. $620 people, damn. Wait, like no one did this contest? For real? Oh no, they did. They just didn't even try Q4. Okay, a bunch of people tried this. And then I guess just no one got this? But why did 2,700 people try this, get this, and then of that 2,700, so few of them even submitted for this? Oh no, they all did submit. Never mind. Okay, we got S, we got T. Smallest permutation greater than T. Wait, why is it tiny? That's so tiny. That makes me think you could just binary search. You could just say, construct this string. Is that big? No. Construct this other string. Could you do that? No. Right? Why would that not work? That makes me wonder, like, can you have like a greedy permutations? Or not greedy, can you have a lazy permutations that just like creates it? R-length tuples. Okay, it yields it. That's, I think, not what I want. Yeah, no. So if I can come up with nth permutation, which I probably have done before. Given n and k, return the kth permutation sequence. Yeah, that's workable. So here it would be 2, 1, 3. You'd have 1, 2, 3, 1, 3, 2, 2, 1, 3. So we can say get the kth. What's the time complexity of this though? O of n. It looks like. X is factorial n. Factorial of 300 is going to be really big though. What is this code doing? I think this factorial n is not relevant. Oh, or it's just really weird code. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 blah. 299, 300. $300, $299, $298, $297, $321. Looks pretty good. Two, 624, 12720. Yeah, that looks right. I'm gonna guess this is too long. No, it's not. Okay, now I can get the nth permutation in what looks like O of n. So with that in mind, I just binary search it and I say get the nth permutation. Is it larger than the target? That seems fine. So that would be strictly greater? Strictly greater. So I think I can literally just say bisect right. Key equals check. Range. It's going to go from 0 to factorial at n. Looking for the first thing strictly greater than target, key equals check. Let's make sure that this comes up with exactly the backwards permutation. Uh-oh, how did that happen? N and K, is this backwards? I guess it was backwards. No, it wasn't backwards. So I probably want factorial at n minus 1 or something like that. Let's see, if you have 1, 2, 3, 4. What about that? Yeah, that's what I'm looking for. Which is good because this range will go up to exactly that minus 1. So based on this, that looks good. Range factorial n, looking for t. Here I'm just saying indices equals get permutation threshold. Wait, what am I doing? No, threshold is here. N threshold. Okay, and then the resulting string I'm looking for is just S at I for I in indices. Let me just check really quickly. For threshold in factorial at n, threshold in range this, print, or no, just check threshold. So it's saying BA is the first thing, BA. Does this work? I don't know if this works. No, there's one more thing I have to do. Thank God. Okay, I was like, okay, I'm just like barking up the wrong tree. I need to say s.sort. That way the permutations will always be in order. So we have the two copies of AB that exist, AABB. Shouldn't there be four copies of AABB? Am I crazy? The small substring's AABB, and then you swap the two B's, and then it's AABB still. Uh-oh. Yeah. Because when you swap the two A's, this is seeing this as like... No. We're not doing that. Fuck. No. Come lay down. Right here. Lay down. Lay down. No, all the way. Good boy. Stay. We're not doing that. Good boy. All right, what I really don't want to do is the annoying like how many palindromic numbers are smaller than this. I like hate doing that. Or not how many palindromic, how many numbers are smaller than this. Oh, and it's a palindromic permutation of S. Okay, well I missed that part. That's important. Wow, I really didn't read this very closely at all. Let's see, so first thing you need to check, I don't know what the fuck I was doing then. First thing you need to check, can you use digit DP for this? I feel like you can use digit DP for this and it would be like not that bad. So is it palindromic? Can you make it palindromic? That's important. So is there only one odd frequency character? That's fine. You're doing good. How big can it be? 300? Couldn't you just build it out every single time? You can do O of n squared. Couldn't you just say like if this is your res you're building, that's like a permutation of S and this is T, you could just say like, okay, well, like, can I have this? If I put an A here, can everything after this be larger than everything after this? If so, and if this is an A, then like I'm golden. And if not, I can't put an A here. And then can I put a B here? So you're going to do that for every single character. You're going to do that 26 times, which is going to do this 26 times, but that's fine, right? You would just go up until you would say whatever T is here, keep going. Yeah, why would that not work? And then it would be a little more complicated. This music's too mystical. Wow. I've been wanting to listen through this album. You'd put a B here and here. You'd say, can I do everything here? Does that work? And there's no DP here. So you're fine to just be like, the moment I know this works, I can just greedily go forward. Let me think about this a little more closely, because I completely just did not anything related to this problem for a minute. It is a palindromic permutation of S and strictly greater than target. So every step of the way you're saying, can I maintain it being strictly greater than target if I do this? And what you would have is it currently strictly greater than target? That's always going to be not true right up until it's true. You're always going to be exactly equal to target or strictly greater. So you're really only ever trying actually 2 letters. Because let's say this is like a D here. Well, then you can't try a B. You can't try a C or any of that. The only option you have is to have a D or say the D doesn't work, so I have to have an E, in which case everything after this point doesn't matter. So then it's just the smallest palindrome you can make. So you keep going right up until you find the first index that you can't set to be the same. Okay, we got that. For I in range n, if something break, this is like you're done. I think I don't really want to write it that way. I think I want to say I equals 0 while I is less than length of S over 2. Let me just quickly. So if n is 3, you have that. You'd say while it's less than 1. So I want less than or equal to, right? Or no, I want to round this up. So this is saying less than 2. That way I do cover this 1. If n was 4, then I'd be here. I'd want it to be still less than 2. Yeah, that's fine. Well, I is less than that. Do something. And then there's going to be if check, and this is literally going to be, can you make res be larger than t still? Else break. Okay. First things first, can it be made into a palindrome? So if length, I don't know, f for f in C dot values, if f and 1 is greater than 1, immediately return an empty string, can't be made into a palindrome. Or else do this, you say, can I set this element to be the same? And then I'm just going to have check here. That's like its own thing because I don't want to deal with that here. If you can, then I guess res at I is equal to t at I. Res at n minus 1 minus I is equal to t at I. So set this and the opposite palindromic thing to be that. And then go up. So I need check to also account for if you're at the center. C at t at I minus equals 2. I think I'm going to do this really like explicitly. If I doesn't equal n minus 1 minus I, you're not in the middle. So do this again. Okay. So then I just need to build out check, right? No, I don't just need to build out check. There's one more thing I need to do. While I is less than n plus 1 over 2. I want to set this I want to set this to be the same. What does that mean? I want to make just, you've gone here right up until you can't set any more values, which means that you've either, this doesn't work, or, which I kind of just want to check later so I don't have to deal with that, or you have empty values in the middle and you just need the smallest possible permutation. So I'll just be like h equals, what is it? Is it elements? Is that what I want? No. Yeah, I do want elements, dot elements. This is going to be all the elements left over. There's going to be one in the middle though, potentially. Right, and that could be not the smallest. I could also just ignore that in the beginning and be like, just set the one element to be in the center the moment you get there, and then I could have this just be n over 2. You just completely ignore the center element if it's set. I think I'm going to do it that way. That's a lot nicer. C dot items, if f and 1, then res at n over 2 is equal to x. Okay, now the odd center element is set. Also want to detract 1. And that makes this simpler, so I can get rid of this and just say you're always getting rid of 2. And now while it's less than n over 2, now you can just greedily set the minimum that you want. And you know that there's an even number of everything. So I think you could just say x equals heap pop h, res at I equals x, res at n minus 1 minus I equals x, I plus equals 1. And then you'll return. Okay, and then the only thing left to do is to say can I at least make something greater than or equal to target? Which maybe there's some nice way to do it that's just like, is the maximum character in S greater than the minimum character in target? I guess that's what it comes down to, right? No, that's not what it comes down to. I think I have to simulate it. But that's basically what I'm doing here, right? So check is going to be, can you place exactly T sub I? Okay, yeah, this is a little too mystical. Can you place exactly T sub I? That's a separate question from can you place anything greater than T sub I? So I think I could just say, if check do this, or else if something, return nothing. This is like you can't place anything. So this would be if max of C dot, I'm going to be really explicit because I could see this running into issues. X for xf in C dot items if f doesn't equal 0. So the maximum thing in the counter that actually has something in it. If the maximum is less than t at I, then you can't place anything. Not only can you not place exactly this, but you can't place anything bigger than it either. Okay. Time for check. So here I'm just recreating the exact array. I kind of want to say like check I, so I at least have the index that I'm at. So I'm really just saying like for j in range I, n over 2, place exactly the thing you need to place. Well, really what I'm saying is like, whoops. So if you're trying to, if there's a D here, you're saying check at I means try to place a D here. And then for anything after this, look at these two. Is there ever a point where this is greater than this? It's a little bit tricky though. The fact that it's palindromic is going to come back. Because you're going to have something down here where you're like, this is greater than this, or this is, if it's less than this, it doesn't really matter. But if you had something where you're like, that's greater than that, then I guess all you need to do is just make it to the center. And then even if it's exactly the same, like it's not increasing. If this is ever less than that, then it's always going to be decreasing. But if they're the same, you just needed something down here that's increasing. But then also conversely, if there's something down here that's less than this, then it resets that. So if like this was greater than this, then that's great. But if this is less than this, then that like undoes it. And then you need something here or up here to be greater than it again. So I kind of want like, do you currently have anything in the suffix that's increasing? Or like anything in the suffix of s that's greater than the suffix of t? Or the suffix of your result? So I think I can just say right here, if t at I, well, no, okay. There's a few things that I need to add in here. Right here, I need to actually set the next value up. The smallest thing that's greater than t at I. So I think what I'm really going to say is like for x and f in c dot items, if f equals 0, continue. If x is less than or equal to t at I, continue. Okay, something, something break. And then this is the actual element you're setting. So res at I equals x, res at n minus 1 minus I equals x. C at x minus equals 2. I'm setting the next greater value, and then I'm breaking, and then down here I'm just greedily setting the smallest possible thing I can. That's fine. Is it that simple though? Can I greedily do that here? Can I just set the smallest thing? Yes. Because up here, I'm explicitly checking, can I make the prefix be the same size? And the moment the answer to that is no, and I make the prefix be greater, then everything after that truly doesn't matter. If it's always the same throughout the entire thing, then I need to check, did I reach the end and the suffix is not greater? So if I is equal to n over 2, I made it to the center and suffix equals 0. I guess I'll just have a prefix. I don't really need it, but then it's not possible. Okay, and then I also need a mid actually, because the center could be greater or less than. And then if the mid is greater, then the suffix completely doesn't matter. Man, what's going on here? Okay, I'm gonna reread it one more time. So I have, is anything in the prefix greater? Is anything in the center greater? Is anything in the suffix currently greater? Build res, find the one odd element, set it to be the center, check if the center, check if mid is changed. Okay, and then try placing at I and n minus 1 minus I. So check to see if you can place t at I, because you're never going to place anything less than that. You're only going to place that or the smallest thing greater than that. So if you can place that, place t at I. That's the first thing that's going to happen there. So place t at I. So say you're placing 2 of them at I and n minus 1 minus I, and then increment. Or else if you can't, then look through every letter you have left. If you don't have it, continue. If it's not greater than t at I, continue. Now you found the smallest element. You found the smallest element that is greater than t at I. So set them to be that, decrease by 2, c at x. Your prefix is now greater, so you're good here. And return. So if you make it here and you ever have any letters left over, the only time that happens is if you weren't able to set this for the entirety of every index. If you were able to do this, then you made the prefix be exactly the same. So I think down here, I'm always able to set the rest of the elements greedily. But it means up here, I need to account for the fact that if you try to make the smallest element you can every time, or if you place all the elements you can, there's a world where you set the prefix to be the same, and then the suffix has to be different. So I kind of want to say like current suffix equals suffix, because I don't want to actually change this. Do I go through and change the counter? That would be kind of annoying if I did that. And it is hashing, and it's already O(n) squared times 26, so like I don't really want to push it. Is there any way to not have to do that? I think I need to. I think there's no way around it. So I'll say C at T at I minus equals 2. Should really be less than 2, but it really doesn't matter because the only odd element up here I have gotten rid of. So there's going to be 2 J loops. There's going to be loop through, see if you can do it, loop through, undo what you just did. Cur pref is pref, although pref is always 0, but whatever. So I'll do that. So check MA equals max C, F equals C at MA. No, that's gonna be pretty. The problem is this is gonna take up like things with 0 values, and I don't really want to be popping from the counter if I can help it. So I'll just say max. How do I want to do this? I'll say X is max X1 F1 for X1 F1 X1 F1 in C.items if F1 doesn't equal 0. This is the maximum element you can place. Either it's going to be greater than the next thing, or it's going to be the same size as it. And if it's smaller than it, then this check doesn't work. So if X is greater than T at J, then you can do it. If X is less than T at J, then you're basically going to return false on the spot. I think what I'm going to do is have another loop where I just say for K in range I plus 1, J plus 1. You know that everything up to this point has been exactly the same. So you could just say C at T at K plus equals 2. Okay. God, that's like a lot. Okay, you can't play this. If you can't place this letter, then you can't do this. Or else see if the suffix still works. Cur pref, I think, is not relevant. Look for the largest thing you can place. If it's larger than T at J, then go back through, undo all your work, and return true. If it's less than t at j, then do the same thing. Go back through, undo all your work, but return false. Or else if it's neither, then current suffix is equal to or equals t, or it's going to be x is the same as t at j in this world. So x is greater than t at n minus 1 minus j. But then also you could make the current suffix not be greater if it's less than it. Let's do another if statement. If x is greater than n minus 1 minus t at n minus 1 minus j, current suffix equals 1. Else if it's less than t at n minus 1 minus j, cursuff equals 0. God, this is going to be a nightmare to debug. Okay, and then in the end, you have placed exactly all of the elements here. So the only thing you can do is see if the current suffix or the middle element are different. Okay. In theory, that should be it. I is 0. Blank.join_res is BB. So for some reason I did not go up. I think right here I'm saying looks like you couldn't place an A, which is wrong. But I needed to say I plus equals 1, which is true. I do need to say that there. Then why did it not see? No, that is true. You cannot place an A here because then they would be the same. So okay, it did correctly recognize that, which is good. It should say here both of these are 0. It should say you're at index 0, you're trying an A, and cursuff, if you placed an A here, you have to place a B here. In which case B and A, you didn't actually change anything. Index out of range. We got a 0 for B and a 0 for A. That's not great. So when I came back up here, it should have said you return the A. It didn't though. It didn't give A back. So somewhere up here I'm missing a C at T at K plus equals 2. Oh, yeah, it's that I finished the range. In the world where this is all exactly the same, I need to just do another J loop. So C at T at J. Whatever, I'll just designate K as the do this pointer. What's going on here? I need this. What the fuck am I doing? No. that's a complete waste. For k in range I plus 1 to n over 2, c at t at k plus equals 2. And then I also need to say c at t at I plus equals 2. So return the ones you used, which for some reason it did. So now I'm worried it's going to say b is 4, which is not right. Yeah, so where did I actually return this? I should really just be able to say that, right? I think right here. C at T at I. No, not right here. This is the world where I'm undoing all of my like removals from the counter. If I have to encode this, that's not going to be that annoying. It's going to be annoying, but it's going to be a little bit of a speed up, so I don't have to hash. C at T at K. So I'm kind of confused. Right here, does that mean that this B was equal to 4? Because it shouldn't be. No, it's equal to 2. And then it goes down to 0. No. A goes down to 0. Okay. No, it's a little bit confusing, but that is true, because I'm not actually looking at S, I'm looking at T. I'm saying, try using up your A. Can you do that? So that's fine. Okay, but then why does B go up? Did I type S instead or something? Two comma 0. I think the problem is actually not to do with the 0th index, it's to do with the final index. So up here, I'm saying for everything in range J, for everything in range J. I don't think I actually ever decreased these though. So what I should say is just C at X minus equals 2, right? There we go. Now we have the two B's back and two A's. Are these very exhaustive test cases? No. BAAB. We got nothing. Looks good. We got nothing. ACA. Well, that is right. So that's good. Do I want to just eat the 5-minute penalty? Okay, well, the one thing I'll test. We got 300 A's. So what happens if we try 300 A's and 300 A's? Okay, it doesn't take too long, and it's fine. So if we said 300 A's and a random B in here, it should be smart enough to say, great, you have a B in the middle, so now it's different. Yeah. And it looks like... Oh no, it doesn't do that. Is that right here? Oh. No, interesting. So it returns early before that. Is that because is it because it runs out of A's? No, you know what I bet it is? In fact, you know what I know it is? It's that there's 300 of them. So it can't have an odd, it can't be palindromic. It's like a separate constraint. This should be smart enough. Okay, and it looks like right in the middle is a B. Based on that, I mean, is there any other low-hanging fruit as far as like test cases that are gonna fuck this up? I figured out the middle. What happens if I say, okay, get it back to 300 A's and 300 A's. What if I said, what if this was A, C, A, and this had two C's? So what I should do is say it's going to be A, C, and then a bunch of shit. And then right at the very end, the fact that this is a C and not an A is going to make it work. Okay, good that I tested this. They're the same length, so that's not the problem. Is it the same thing? Is it up here? No, it gets that. So where is it just straight up returning false? That has to be right here, right? Etched. So it looks through the entirety of C.items. It says, I don't have anything left. It says T at I is C. But there should be a C in there. There is. And it should say that works here. So it says, for A, you can place an A, and there's something that will work. But if you try at index 1, well, wait, T at I is C. Why is this saying, oh no, it's saying 1 because check at I is returning 1. Somewhere I typed a 1 instead of a true, but that's fine. But then for index 2, it's returning false. Oh, excuse me. But it should say, just place a C there, and then you're good. So at what point here does it not work? Gotta get rid of some of these print tests. That's fine. Return true, return false. It should say right here, current suffix is true. And mid is false. Okay, it does. But then it says current suffix is false. I think what's going on here is I'm printing. Let me do. What are we actually trying to test here? Yeah, so it's saying for index 0, current suffix is true. For index 1, current suffix and mid are false, but that's not the case. Right? Did I put a C at the end? No. Oh, I'm forgetting one more, which is for I itself. If you set I itself, does the current suffix at n-1 minus I, not n-1 minus j, does that also work? So cursuff equals suff, or T at I is greater than t at n minus 1 minus I. Okay. Now it's saying true, which is good. But then the current suffix is not being appropriately set. So I think I'm forgetting to update suffix somewhere. Oh man, what an annoying problem. I did the first 3 problems in like 10 minutes and then this one really fucked me up. Pref is 1, that's fine. Here I want to say suffix if t at I is less than t at n minus 1 minus I, suffix equals 0, you have to reset that. Else if t at I is greater than t at n minus 1 minus I, suffix equals 1. It's now greater. Wowie zowie. Okay. What if we have a world where it mattered? So if you had A, B, A, B, A, and this was A, B, A, B, A, the only thing that will work is B, A, 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 B, which it should recognize. Okay. Now if we switch it up, there's one more thing that's very like stupid. It's a corner case, which is if the center element, if I said A, B, A, B, A and A, B, C, B, A, it's not recognizing that the center element is smaller. So this if pref equals 0 or mid equals 0 or and mid equals 0 and suff equals 0, this is saying if it's the exact same string, if there was no point where it's greater, then it doesn't work. But I also need to say if pref equals 0 and I'll just say mid equals -1, this is like it's actively lower than it, return nothing. And then that would be up here. And the only way this can happen is if this else clause never goes through. And the only way this else clause can never go through is if the prefix is always exactly the same. This one's so fucking annoying, dude. Oh my god. And it's like I see what needs to be done. It's just like, good lord, there's all these corner cases. Okay, there's 2 more things I need to do though. So, or no, this is the final thing that I can tell at least right now. I'm trying not to rack up a bunch of +5s, but I'm starting to be like, no, I think it's a good idea that I'm not. Because if I did, I think I would be like really annoyed right now. But the fact that I'm trying to figure them out on my own, like it is really annoying, but at least it's not, I'm not seeing the like failure, you know? This one in the tree problem. Oh yeah. Yeah, I finished that tree problem, by the way. That one was really satisfying. Okay, what was I looking at? So I'm saying if there's no difference in the prefix, which doesn't really matter because if there were a difference in the prefix, you're pretty much returning right here, right? No, that's not really true. The way I've set this up, that's not the case. And then mid here is, if it's -1, it's actively less. Yeah. And then I think I can just kind of say, okay, mid is equal to x is greater than that minus x is less than t at n over 2. And Lord is my witness, I'm not going to be fucked over by this order of operations. So if it's less than it, then it will be -1. And then if it's -1, it doesn't matter what the suffix is. But if it's 0, that means the middle element was the same. And if the prefix is the same and the middle element is the same, could this ever invalidate that? Because here I'm saying if there's anything left for you to place in the whatever it's called, palindrome, then like place it. But that could invalidate, if you place something here that's less, it could invalidate this. But the only way that there will ever be anything here for you to place is if this element was greater already. So I think that's not a problem. So now this should say, no, that doesn't work. But if I change this to a C, let's say, then it should work. BACAB. That sounds right. Okay, I don't really know what else to test. I think I'm going to start just running random test cases. BAAB looks good. Looks good. ACA. All right, I got to just start eating wrong answers here. 729, that doesn't really mean anything. AAAABBBB, ABBAABBA. So I'm saying BAAAAAAB, but I need BAABBAAB. Okay, that's a really simple thing to fix. I don't know where the problem is there, but what I would imagine is happening is that I said at the very beginning, you can't place an A here. So if I print I, it should just print 0. Yeah. So it said you can't place an A here. Okay, so instead place the smallest thing you can above A, which is probably going to be B. Yeah. And then it said greedily place everything you can after that. And for some reason, there's an extra set of A's and not B's. So it took away the wrong thing. C at x minus equals 2. These are equal to x. That's fine. So does the problem originate here? 4 A's, 2 B's. That's right. Mine is spitting out 6 A's and no B's in this range. So let's see what H has got. It looks like it's not real. Oh my God, I'm such an idiot. I'm making a new heap every time. That's so stupid. Okay, well, that was an avoidable error, but whatever, I'll take it. That's much better than something more insidious. Damn, I'm losing it. BAABBAAB. Let me look this over. That was the most basic thing for me to whiff. So I make a heap of all the elements. I heapify it. So it's what are all the minimum elements? Pop it, add it, go up by 1. Looks good, I guess. Okay, what do we got this time? VGHVG, GVVFG. So where does mine decide that it doesn't work? Is it here? No. Is it one of these? Yes. It said, if the middle element for you, if your middle element is less than their middle element. So this one, the middle element has to be an H. This one, the middle element has to be an F. So A, B, C, D, E, F, G, H, I. Let me run through that again. This is where I'm at. A, B, C, D, E, F, G, H. So H is just straight up larger. So that's very surprising to me. Right? Am I crazy? Is this backwards then? X is... So it should say this middle element is, this is -1 right here. So what is it coming up with? It's saying your middle element is X. Okay. No. That's right. That's totally right. Yeah. No. So their middle element is not F. That's nonsense. G, V. I mean, just immediately you just place a V, right? So probably the problem is I'm not actually setting the prefix to be larger. Mid should be smaller. That's true. So right here I say prefix equals 1. Does that not go through, or what happens there? Okay. God damn. Okay. So the problem is that it does work. You could say GV something VG, but then the middle element doesn't work. So it should have recognized that, and it actually should have recognized that here. Okay, it's not all hope is lost. That is a very annoying corner case though. So here, I think it's that, okay, no, simple fix. I'm saying cur, suff, or mid. I don't want this. I want to say if mid equals -1, return false. Just if the middle thing doesn't work, then it won't work. Don't do cur, suff, or mid. VGHGV. Okay, looks good. Do I have any print statements left in here? I don't know, maybe. 6 more test cases. K, U, 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 K, U, U, K, U, 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 K. That's actually really odd that it would even have any issue with this. So what does it build out before it quits the... Nope, I was looking at the wrong test case. Okay, that's nothing. Does it make it up here? Yes. So that means probably right here. Yeah. So it says that the second index, you needed a U, but there's already a U. This should have been caught by the check function once again. The check function should have said, if you try to just go through and place the largest thing you can, it doesn't work. For if you place a K here, because I'm guessing that's what it's trying to do. I should see that C at K is 0. Yeah, so it said you can place a K here, and then it did, and it said, okay, now it doesn't work. If mid is -1, return false. That's fine. Is I here? I is 1 and 2. That doesn't really mean anything to me. So it said right here, just keep placing. Oops. So you're testing, can I place a U here? And it's saying, yes, you can place a U here. And then the next thing that you'll have to do is place a U here, which is true. But then it says, can I place a K here? And for some reason it says, yes, you can. Even though you cannot. No, wait, why wouldn't you be able to? Why couldn't you say UK, UUKU? No, because it's UK. Damn it, okay. So it's something with the suffix that's fucked up. Yes, you can place a U. Yes, you can place a K, except that's wrong. I, cursuff mid. So it's saying current suffix is 1, which is not true. Current suffix is not 1 if you place a K here. Because it said you placed a U and then a K. These are both U's. That's the only thing that can happen. And then you have KU versus UK, which is not true. So where did cursuff get set to be different? Not there. What about here? So cursuff is already set to be 1. Which is true, because it's saying you placed a U here and a U here, but that's a K. So that is true. Okay, and then it says find the maximum element you can. If it's less than, yeah, that's right. If X is less than N minus 1 minus J. So why did this not go through? X is U, T at J is U. Okay, it's that there's one more I'm missing. So right here I'm saying cursuff equals suffix or T at I is that. What I really want to say is cursuff is suffix. If that, cursuff equals 1. If it's less than it, cursuff equals 0. Oh my god. Wow, that is the most I've ever zoomed out in one moment. That was the most specific imaginable little tiny snippet of code to go from that to, oh, submit, got it. What even, that was like 5 seconds ago and I already don't even remember what I just did. I think my thought process, it was like I'm not even able to really verbalize it, but my thought process was like, if you place a U here, that's fine. If you place a K here, it's not fine. And the reason why is because you would have K and then U versus U and then K. And what it's doing is it's checking what about everything in the suffix and later in the prefix, does it work? And then I remembered that I forgot to check the thing you placed itself in the suffix. I didn't forget to check the thing you placed itself, but I forgot to check if the thing you placed invalidates the previous suffixes. Man, what a corner case. Wow. Well, that was a pretty poor performance for me, but I mean, I don't know. There's hopefully a bunch of these contest cheaters get kicked out and then my little virtual score goes up. That's got to be close, like close to 600, 700. Yeah. Whew. That's crazy. I'm kind of like, that's one of the most annoying problems I think I've ever had. Like, seen. It reminds me of this game of Dota I was playing one time that lasted 2.5 hours. They released this skin one time where, like, if you won, you got some reward, but if you lost, you didn't. So people would just join lobbies, and then the moment they thought they were going to lose, they would just feed to end the game earlier. And there was 2 people that were doing that on my team, and it was like the most irritating imaginable experience. But like me and the other 2 people that were like trying won. And it's like weird how there's this very thin line between being extremely irritated and like feeling victorious. That's kind of what this problem reminds me of. The Dota experience. How was I so certain? I think the part that I'm actually like, okay, I did this right. The thing I did wrong was that there were a bunch of corner cases. I don't know. There was a lot of moving parts, and I don't think I handled that very well. It's like if I'm a barber and there's like a bunch of hair all around someone's, like I'm trying to cut their hair, and like I'm doing a good job with the actual part I'm cutting, but I'm not doing a good job of managing all this random shit all over the place. But the thing I did well, I think, was like sticking to, okay, this will work. It's going to be a finite number of corner cases. I just have to like get as many of them as possible before submitting, and then submit and just keep going through them. And I think I worked through like 3 submissions. Because like there's some point where like I was pretty close to being like, okay, I guess my solution's not very good. I just felt like I'd proven it to myself. It was just a matter of all these tiny little things I was forgetting. Well, there's a contest. I've been thinking about this problem for a while now, like 2 weeks. I kind of want to finish up multidimensional queries. I don't know how interesting that is to watch though. I could also alternatively, there was like Codeforces duels, I think it was called. Looked pretty interesting. Whoops. What do I want to do here? They got the little Veet create icon. That's funny. If I move this, does that still show up on the stream? Yes. All right, well then I'll make an account off stream, I guess. So this is saying define f of I. It's saying define f of I to be basically what I points to. So f of I and 1 is a at I. F of I and m is a at f of I and m minus 1. Which is very formally put, but it's saying if you have an array, let's say you have like 1, 3, 2, 6, 3, 1, 6. Okay. So it's saying f of 1 and anything is always going to be itself. If we take like f of I and 1, you're saying, well, this points to its own index, 1 indexed, 3 points to this, 2 points to this, 6 points to this, 3 points to this, 1 points to this, and 6 points to itself. And then if you said f of I and 2, you're saying, okay, now you're not looking at the parent, you're looking at the grandparent. So like we can immediately see, well, 1 points to itself and then itself again. So it's to itself. 3 is going to point to 2 and then 3. So it goes there. 2 points to 3 and then 2, so it's itself. 6 points to 6 and then 6, so it just points to 6. 3 points to 3, which then points to 2, so this points to 2. And 1 points to 1 and then itself, so this. And then you keep going, so f of I and 3 is going to be like everything points to the parent of the grandparent. Which I think it's like a somewhat complicated thing, like a jump table or like binary lifting. That's fine. That's like a thing you see on Codeforces, but this one's confusing because it's not, the reason why it's a div1h is because it's not normal binary lifting. It's not asking you, here's a query, what's the 10th grandparent of node 1? It's saying, give the answer on Q queries. Each query consists of 2 numbers m and y. For each query, determine how many x exists such that f of x and m equals y. So if you had f of, or let's say q of 1 and 3, it's saying how many nodes are there where their great grandparent is node 1, which is a much harder question because there's no easy way to like self-compose this. Right? What you need is some sort of like, this is a composition of Q1 and 1 and Q something and something, or 1 and something and something and something. Like, how do you compose these? You need a way to construct that jump table. I don't think, it's not a permutation, is it? No, it doesn't look like it. So it's not a permutation. So you could have multiple, and in fact, if it wasn't if it was a permutation, it would be a really easy problem because you'd never have 2 6s, right? You'd always have a 5 and a 6, so every step of the way, this is just going to be like that, and then something else, and then something else, and then something else, and then something else. It's never going to split into 2. So if this were a permutation, it would actually be a really trivial problem, but it's not. But maybe that's part of the key. Maybe part of the key is you say, well, hey, there's 2 things that point to 6. Let's say we had, and this is 1, something like that. You'd say, well, there's 2 things that point to 6, and then this points to 1. But what you could really say is how many things point to 1? 2 things. How many things point to anything that points to 1? Also 2 things. There's another split here. And then you would just go down and down. You'd say how many things point to this progeny, this grandchild of a given node. But it's still not obvious to me how you would compose that in O of 1. What is this? Oh, you got it. Did you also just like debug and debug until it worked? Looks like it. Oh my god. dude. I mean, okay, canned, great. Target, great. SL, great. When you start getting into O at I, I'm like, I think this is maybe I hope this is a language barrier, because like I would not know what any of this meant. Can't continue or can't continue without overcharging there. What a nightmare. Oh, it's just like my answer that I construct. I see, okay. This is such long code. It's so long. I think yours is actually shorter. $87, no, 92, but you had a lot more spaces in between. So it's almost exactly the same. Something else I feel like I did well was like I had like I bothered to name these. Like I don't think I needed prefix. I think at anything after this point, you have other ways to know if prefix is equal to 0 or 1. You would have known. But I don't care. I'd rather not have that mental overhead. I think this is just an AI honeypot. Yeah, I think so. I assume by that you mean like it's a problem just to confuse AI. So if it was, what is the nth ancestor of this node? You can get that pretty quickly. No, I mean AI can probably solve it 100%. I kind of assume that a lot of why they phrase things the way that they phrase them is specifically to confuse AI. Like, it's actually kind of heartening to see that for this problem, only 2,700 people got it. I mean, I hate to say it, but like, it's pretty much just a basic parametric search problem. You have to make like a kind of complicated observation. So like 2,700... Back in 2002, 2000, like before there was LLMs, this is about how difficult I would clock this problem, like about this many people. And I feel like the reason why they phrased it this way was they put like a little bit of effort into being like, okay, you can't just feed this into AI and it'll be like, that's exactly the same as a previous Leetcode problem, but with one change. They were like, we'll make it the same as a previous Leetcode problem, but with one change, but we'll change the fluff around it and like phrase it confusingly. And it took me a little bit to like even understand what it's trying to say. But I think it did help it not be completely overwhelmed with AI. I don't know, but when I looked at Q4 though, I was like, really? Only 600 people got this? And then the more I was like working on it, the more I was like, nah, this is one of those horrible string problems. Like, now that I look at it, I'm like, I'm very surprised that 600 people got this. Like, I think my implementation skills are pretty solid, but I had like an hour and 20 minutes to do this. The idea that there was 600 other people that did it, probably in a shorter time frame, like I kind of don't believe that. I think they must have used AI. At least in, like, not everybody, of course, but when I saw the title of Q4, I knew it was going to be like that. Lexicographically smallest palindromic permutation greater than target. This shit I can't stand. I'm actually really glad it wasn't. I'm glad it was O of n squared, because there's a world where they make that O of n. And that would be... Well, maybe I'd prefer that, because this was just a lot of string manipulation BS. If it was like just some O of n like observational thing, maybe that would have been better. Is this Tycho? No, it's Boards of Canada. It's either returns the kth lexicographical, hate everything lexicographically smaller, thing satisfying. Yeah. Yeah, and I spent like half an hour like searching around. I was like, oh, it's just obviously this other Leetcode problem, and it wasn't, because I missed the word palindromic, which is pretty bad. I don't know what my thought process was there. Div1H, but like, This seems weird. I don't know. This seems like not a normal div1h. I don't know what the hell bubble cup is. Oh wait, no, I do know what bubble cup is. Is this the weird Eastern European one? Yeah. These ones are hard. I did a couple of these. Like some of the rules here, or some of the... let's see. Some of the questions. I'm not even going to look at these. I'm already looking at this one. Are you sure? Have you seen the editorials of Div1h? They're crazy. This just seems like such an elegant problem that even if the editorial's really complicated, I call it hubris, but I'm at least going to be able to understand it. Like, the conceit of the problem is so simple. And it doesn't have an obvious solution at all to me, but that makes me kind of be like, there's something to be gained here. There's something to learn. Like, if I was only doing Leetcode for a year and someone pulled up this, I'd be like, I'm not even going to try to understand it. I don't care what this has to say, you know? But if it's something that's like more high concept. So my two thoughts here, where my mind goes with this, I think also Bubble Cup is like a much smaller competition. I don't know. I think it's like team based. I think it's one of those. So my thought is, so you compose A into A. Yeah, it's just tricky because it's like, with what? You know? I don't know. I'm thinking, so if you have A, and I'm not going to write out the actual elements, but you have everything has a parent. I'm thinking there's a couple ways this can go down. So let's say this points to this points to this points to this points to itself, this points to this points to this points to this, and this points also to this, something like that. Just a random distribution of parents. A is not a permutation, so far as I can tell. And that's something I was saying, I think probably before you joined, was A is, pin that. If A were a permutation, this would be like a trivially easy problem, right? Because then you'd never have like two nodes pointing to the same thing, because that means there's two of the same value. So if there were two of the same, if this never happens, you know it's just going to be a bunch of cycles, and then the answer to everything will always be 1. So A is not a permutation, but they are always between 1 and n. So at least that. M is 10 to the 18th. That's just, I mean, they're just straight up telling you, like, this is some sort of binary exponentiation. There's no two ways about that. 0.5 seconds. I think it's fine, honestly. Oh my god. At least in C++. In Python, yeah, I mean, yeah, you're fucked. But as am I. Because, so, oh, I was going to say, so there's two ways this can go down. Either one, there's just an honest to God. I'm just going to call this a forward composition, or straightforward. Composition. So this means like Q of I and J. I'm not going to say I and J, I'm going to say I and X because that's a value, not an index. Is going to be indicated through Q of some sort of J and Y. And Q1 of K and Y. And maybe more. It's just going to be some sort of composition. I have to figure out what that is, and then I'm good to go. That's one thing that jumps out to me. Well, this has to be binary lifting. Yeah, but it's not that simple, right? Because like yeah, that's probably a layer on it, but it's not asking what's the nth ancestor. It's asking how many of the nth descendant do you have. So I'm thinking, and straightforward composition would basically be that. So this would be something along the lines of like, something about binary exponentiation or something along those lines. I mean, it always will be, but this will be almost exactly a jump table. Or I'm thinking maybe it's some sort of like aggregate. Across queries. So you're not asking how, like you're not saying individually for this query, what's the answer? Individually for this query, what's the answer? You're saying take everything, jump once, jump twice, jump 4 times, jump 8 times, garner some sort of information about that. Why would you not be able to do that? You would have O of log of m, which is large, but that's fine. O of log of m times n. You'd say, for any given number of jumps, this is the state of the board. This is the number of values there are at everything. So at 0 jumps, you'd say everything is just itself. At 1 jump, you'd say everything is at its parent. So there's something here, there's 2 things here, there's something here, 2 things here, something here, nothing here. And then you'd keep going. You'd exponentiate that. And then to resolve a query, you could be like, well, if I need like how many things are there going to be 5 jumps ago at here? How many things will be here in 5 jumps? I would say, well, that's going to be everything 1 jump ago. And then I need some way to compose that. So this index and this index, how many things are going to be at each of these in 4 jumps? But the problem is that's O of n log n to build that table. That's not O of n log n to solve that. Or it is O of n log n per query, but that's nowhere near good enough. Unless you treated the whole jump table like a DAG. Could you top sort it? Would you be able to do that? No. Because if you were looking at some node and you're saying 5 jumps ago here, where was I at? You're going to be at some random distribution of nodes 1 jump ago, and then each of those you're going to be asking for. But that has like absolutely nothing to do with the node that you're at. So I don't know what aggregating across queries would look like. How many x exists such that f of x and m equals y? I've done 2 bubble cut problems before, and they were like pretty well written. They were like a little bit thinking outside the box. Like they were the kind of thing where this would actually use square root decomposition somehow. It's weird. Like, in my mind, this occupies a place of, if this is my brain, this is my peanut brain here. And this occupies the place of like won't work. It's like trying to think about composing this backwards. Like all of my intuition is telling me that's impossible and won't work. Because you can't just compose whatever. You can't just be like, if you can exponentiate a number in log m time, can you exponentially get the derivative in log n time? Like, probably not. Or like get the exponential root in log n time. So what this will be is kind of just some sort of DP array. And maybe it represents something different, but you could say at index I at jump j. And it would be easy to say, what is the actual content of this? You could be at the ancestor. That's the thing that I can easily do. There's also, you can have the number of descendants. Of I, which is the question, and I have no idea how you would be able to do that, but that's what we're trying to figure out. Every jump is going to encounter a cycle at some point, and it can only be a length of n or less. And it's only going to encounter each node once in the cycle. So you could say, where is it on the tail? Where is it in the cycle? It's going to be modulo some rate at which it's going through the cycle over and over again. So if we take a really simple example, like this. Favoritism. So if you have this, let's say this is node V and this is node U, and you're querying U, you're saying, I want to know for node U something. You could pre-calculate for V, okay, it's going to encounter this cycle. That's kind of weird, but maybe. You could say it's going to... Wait, I think I pinned the wrong comment. Yeah, I just pinned a random comment. That's funny. Okay, we'll pin that one. Didn't I mean to intrude, but did you do the weekly? Yeah, I just did it. I wish I could see like when I got each question. Oh wait, I can see when I got each question. I didn't think about this. No, wait, I can't. Right? I can click on it, but I don't think the ranking works. Like, I think once it's done, it's done. But maybe I go look for like the 600th place. CPR. What does that mean? 571. I don't know why it would be there, but what the fuck? Look at this person. So they finished the first two in 8 minutes, and then they spent an hour and a half on this problem? What? Why did they spend so long on this? Oh, C-list. User Glump 1, those bets some same, eh? Glump.net, Brendan, who the fuck is this guy? BetSimp LinkedIn. That's the associated search. That's so funny. Bets. That's so funny. No, I think I just go to... No, wait, no, I this won't work because I didn't do it live. That's like the problem. What happened here? What did this person do? Wait, what? Oh, this is, okay. This is Leetcode being janky. It's like you still wanted to look at the 571st person only in China, and no, because they probably got a much higher. I just want to see what the hell the replay was if they... whatever. It's just weird to me that they spent an hour and a half on that. But yeah, I found the contest to be, I think I did the first three in 10 minutes or maybe 15 minutes. And then the fourth one I got literally 1 minute before the end. Oops. Just because there was like so many corner cases and I knew my code would work. I'd proven it to myself, but there was a bunch of tiny little things that was like, what makes you think of BS for Q3? I guess that's a good question. I didn't think it was like easy. I think it's easy for me because I've seen these questions 100 times, but like, yeah, it was a problem. I think it would have been a little hard for Q2 and it was reasonable for Q3. For me, I'm always like, okay, I know a solution can work. I actually want to do better than that. I want to go for a solution that's going to not take any effort to actually code. And that's why I hated Q4 because it took so much effort to code. So for Q3, I'm like, yeah, you probably could do some kind of simulation, but that just sounds like a massive headache. Like there's going to be some modulus thing. And that sounds really weird. Like having to just do each, like, no, that's okay. So I was like, well, I think this is kind of the Codeforces in me. I think I just was like, you're kind of just looking for, I don't know. I just asked that a lot with questions. Like, if you already knew the answer, how could you validate it? That's like a really valuable thing, right? To like think about. And I'm like, well, I know how to get the answer really quickly. Like for Q4, there's no way to just figure out all the permutations and then do the right one. That's actually what my code originally was before I saw the word palindromic. Was I literally just copy pasted another program or another solution to a Leetcode problem. With this though, you know you're going to come up with a number. You know the number is either going to work or not going to work because it's saying the minimum total time in hours required. And it's not like some time will work and then sometime after that won't work because you could have just finished. If 5 minutes works or 5 hours, you could just finish in 6 hours and wait around for the 6th hour, right? You could just finish at 5, sit around for 6, and then you're done at 6. So like, you know, there's monotonicity. So therefore a binary search works if like that kind of condition for the binary search solution works. And to me, just like I can kind of just observationally figure that out in a few seconds. Then the question is like, well, how would you validate it? And that's kind of juicy to me. I want to think about that because I'm like, that's so much easier to code out than like a simulation or some weird greedy heap thing. And I was really worried it was going to be that, because I'm not good at those. Greedy heap would work. Yeah, you would need a way to say when both of them can do a task, which one do you want to do the task? Right? Which would probably just be the one, if I'm really thinking about it, this is how little I thought about that solution. It would probably literally just be if drone 1 and drone 2 can both do one of their tasks, which drone currently is going to finish later, just have them do their task first. And then you would just naturally kind of like, they would just take turns. But I'm still like, if one drone's going to finish later, but it like does every other, it has to recharge every other turn. I just feel like there's still room for some weird corner case where I'd be like, nah, fuck that. So my thought process was like, can they finish in a certain time? I know if I can answer that question, the problem's done. There's really only 3 bottlenecks ever. There's, can a drone do all of their tasks? So like, find the amount of times they have to recharge. Subtract that from the number of days you're giving them. Do they have more deliveries than that? Do that for both drones. That's 2 bottlenecks. The third bottleneck is if they have to share, how many days do both of them have to not do anything? I think that's like not super obvious why these are the only 3 things, and if you have these 3 things, like, it just kind of works. I did draw it out somewhere in here. Yeah, I drew it out and I was like, okay, if they coincide on this day, then blah, blah, blah. As far as explaining how I would like reach that, just empirically drawing it out, I think was a big thing for me. But I think there is something really uncomfortable about like this kind of thought process where you go, well, if on line 6 this condition is true and this condition is true and this condition is true, then I know necessarily there was some sort of configuration that works, even if I don't care what it was. That's kind of uncomfortable, because I guess then that's my next thought process is like, well, what would be a world where these all are true and it doesn't work, and I can't think of one, so I'll just try it and risk the wrong answer. That makes it sound pretty like irresponsible, but I thought about it enough. I was like, it's very unlikely I didn't think of something. Like, I basically have proven this to myself. I was doing greedy heap, but then it was failing. Yeah. And that's the thing too, like the code I just pulled up. It's not only is it easy to write this is really easy code for me to write. And even like is this bisect left or bisect right? Like, that's really actually easy for me to think about. But it's really easy to conceptualize and prove. If this is some greedy heap thing, for example, this is really, I'm surprised that I proved to myself enough that I never lost confidence in the actual solution. Because this is really complicated, like the implementation and everything. And there was a few points where I was like, oh fuck, everything's ruined. Oh no, wait, I just need this one line and then it's fine. I guess that's another advantage, shortcode. The general idea for Q4. Whenever there's these problems that's like the lexicographically smallest permutation with something, the thing to recognize is that there's an inherent greedy formulation here. Let's say you have some string S that's like ... and you have your counter of S. Just to like kind of simplify it, because it's a permutation. You're moving them around, so you don't really care about the order. You just care about the count of all the letters. So maybe we have like 4 A's, 6 B's, and 1C, something like that. So if you're looking for the lexicographically smallest something, which is res, then you're going to just say, like, can I have an A here? If I can have an A here, I never ever need to look back at this choice, because the moment that this is even possible to do, I'm never going to want to be like, oh no, wait, I wanted a B. Like with like some DP formulation, like that's going to be the case. But here there's an inherent greediness to lexicographic comparison, because it's like, it doesn't matter if these are all Z's from that point on, and you're comparing to some other thing that was like B, A, C, A, whatever. Like the moment that there's an A, it's just A is less than B, therefore it comes first in the dictionary. So that's kind of the first thing to recognize. Like there's a greedy formulation here where you probably want to be doing something along the lines of put a character here, can you do it? And that's pretty much exactly what my code does. Like it's just a straight up greedy traversal, where I also recognize I can just do O of n squared times the number of characters there are. So O of n times 26, which you don't even need. I think this is just O of n times n, because but the general idea is I say, I have a check function. I just say, can you put an A here? Let's say target is like A, something. So I want to check, can I put an A here? And what it means if I put an A here is everything after this point, I can still make this greater than that. And if I can't put an A here, then I look for the smallest letter that I have, the largest letter, how do I put it? The smallest letter greater than A, which is a B. And I say, okay, well then a B goes here. And then everything after that doesn't matter anymore because B is greater than A. So no matter what I do here, I can just have the smallest thing. Or I do put an A here, and then I continue on to the next thing. And let's say I can't put an A here, so I put a B here. Well, that means like, what do I have? 3 A's, 5 B's, and 1 C left. So then I would just do A, B, 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 dot, 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 dot. It's just like the shortest thing. And then in the center, I'd have to have a C. But, and then the question is, okay, well, how do I check? Like, can I put an A here or not? How did I know that I could put an A here and I couldn't put an A here? I just literally went through. What about the palindrome? Those are weirdly less intrusive than you would think. But basically what I do is I just say, or the solution, I don't know, Solaris has looked pretty similar, is here, it's like, okay, try putting an A here. What does that mean? Well, this whole thing takes O of n to like actually try every letter. So that means when you're trying a letter, that check function gets to itself take O of n, because you're making O of n checks. If you are budgeting out O of n squared, you get a factor of n. So you can just say like, okay, we'll try everything here. Just fill it out with the lexicographically actually largest possible thing you can do. If anything works, then you know that you can place an A here and then continue. If nothing works, if it's too small, you can't place an A here. You have to place a B or a C if you didn't have any B's. The way that palindromes are handled, that's the part that actually gets like really confusing and corner casey here. But something that sometimes shows up is you have, there's a greedy formulation of, can you place an A here? Can you place a B here? That's fine. Every time you place an A here, you're placing an A here and a B here and dot, dot, dot. And you recognize, let's say at the end of it is A. That's at the end of target. Well, the moment you place this B here, you're saying, okay, so far, and let's say this is a B, just for the sake of this example, I have A, B, and then something, and then the target is A, B, and then something. But this ends in BA and this ends in AA. So you keep track of that and you say, okay, right now, if this was all exactly the same right up until the suffix, it works. Like it is greater, even if the prefix is the same. But the moment, let's say you put here A, and this is A, and then here you have A, and then this becomes, no, that's a bad example. Let's say this is B. Then you'd say, well, now the suffix is smaller. So just like how here you're always greedily changing it because the moment that this changes, nothing after it matters. It's the same at the end, except you're going backwards. So you're just saying like, okay, now the suffix is larger lexicographically. But once this A is inserted, now the suffix is smaller lexicographically. and you keep going back. The only other part that's basically exactly the same code that's pretty confusing is like here you'd have to put a C in the center, right? Because there's a single C. And so here, if this was all A's, it wouldn't matter that this is small lexicographically if the center here is an A and the center here is a C, because again, like this kind of blocks everything after that off. So the idea is I just keep track of, okay, you have 3 substrings. You have prefix, middle, suffix. Are they all lexicographically greater or not? And then you need to actually be like, well, if middle is lexicographically smaller, then you need prefix to be greater. It's not enough to have suffix be greater. That's kind of a detail, but that's pretty much what it comes down to, is like reconciling these 3 things and just keeping track of them. So here I say, like, can you place the exact T at I at answer at I? If you can, place it backwards, see if that changes the suffix. If you can't, look for the smallest thing you can place that's above T at I. If you can't find that, then you're screwed. Yeah. And then at the end I say, if the prefix is the same but the middle is less, then return nothing. If everything's exactly the same, return nothing. And then if you have anything left over, just like greedily put in the smallest thing you possibly can. Because at this point, you know that the prefix was greater if you have anything left over. Not the worst conceptually, or like in terms of what the solution is. It's like a greedy thing, which if you've seen these a few times, you know that like lexicographical ordering problems like this typically are sometimes binary search, but most of the time like greedy in order of index, because like lexicographic sorting is like inherently kind of monotonic based on index, I guess is the best way to put it, or greedy based on index. But the implementation was pretty confusing. So if I have V, I forget what you call this when it's not a directed acyclic graph. It's a, is it called a functional graph? Directed graph where each vertex has one outgoing edge. Yeah, that's what I'm looking for. So every node has one outgoing edge. That means every node is part of one of 2 categories. It's part of exactly a single cycle, or it's part of a tail that leads to a cycle. Right? Yeah. So for this one, the answer will always be between 0 and n. It's asking for each query in this functional graph that you have, how many descendants are there? How many of the nth descendant is there for x? So for u, for example, if you said like f of u and 1, you'd say, well, it's its own descendant, so we have that, and also this thing. And if you said f of u and 2, you'd say, well, it's again its own descendant, and we have this, so there's 2. And then f of u and 3 would be itself and this, and then f of u and 4 would be itself, but this doesn't have any descendants, so the only thing where if you just like traversed it 4 times, you'd get it again is it. But it's tricky because you could have f of u and 100 billion. I guess you could say if it's ever greater than n, there's no cycle greater than n, right? So the answer is either going to be 1 or 0. It's just how far away is it from the end of a cycle? Or is it in a cycle or not in a cycle? Yeah, thanks for talking, Vortism. See ya. So then that's one corner case, right? Yeah. So then I know from that point on, for any f of u and x, the only unanswered things I have are f of u and x such that x is less than or equal to n, or I think less than n. These are the only ways you could ever have any value that's not 1 or 0 and immediately calculable. Does that help at all? Now you have the same jump table. That doesn't really help. You just know that now it's n log n instead of n log m, but that didn't really matter. Oops. And you certainly can't do O of n squared unless you actually can, because it's 2 times 10 to the 5th. But something I've seen previously, literally with the bubble cup problem, is they said, let's say you have, this is kind of a digression, but let's say you have like some grid, n by n. So you could say there's O of n cells, which is true. Well, that doesn't really mean anything. There's O of n as in n by m. And then you kind of, I feel like something that people do a lot of the time is they just kind of talk in lingo and they're like, oh, it's O of n or O of n squared if you need to look at every cell twice. Or every cell for every time you look at every other cell. But then something sometimes that shows up is you say, well, really what I want is I say, take x as like the min of n and m. And then I'll find a solution that's O of x squared times, and then we'll say y is like the max of these, the other one. X squared times y. And actually what this is you would think this would be O of n squared, but this is really O of n square root of n. As far as this is concerned, as far as like the number of cells is concerned. I could see this showing up somehow, where if you said, I have an n by m jump table. That's kind of weird though, I don't know. Oops, I'm gonna just close that. So what's the direct formulation? You're saying f of u m is equal to for all v f of vm minus 1 in 80JU. We'll say everything that points to u. But another way to write this is you could say for any FU M, it's going to be really similar. Except you could say it's not for all V in 80J at U. It's for all V in, yeah, I guess I'll say 80J at U at M. F of V M over 2. So you could compose it exponentially, is the idea. The only problem is that there's going to be O of n of these. Can I solve this right now? Is this immediately solvable? Can I solve it linearly? Yeah, and I can solve this too. I can say, for every node, if you're looking at your children or your grandchildren or whatever, you have this amount. Then for the node that you're looking at, for your parent, add that amount in, right? Yeah. And then we can do a similar thing here and say, okay, well, F of parent at V at M, so the mth parent up, plus equals F at the M. That just only helps if it's a power of 2. But maybe here you aggregate it and you say, no, that doesn't work. Right, I can do this. This part's not that bad. So I can solve it only if I care about powers of 2. So then if I had some f of u, and let's say 5, if I had f of u and 2, this is just immediately solved. If I have f of u and 5, wait, isn't this just it? No, it's not this. This is O of 1. This would be, you'd say, okay, well, this is going to decompose to f of v and 4, which is solvable in O of 1, for all v in f of u and 1, which itself is not really solvable because you're getting a frequency. This is like all of the elements. So this would be O of n, log n. But you could also say, in a functional graph, there will be exactly one descendant node for any given node. No, one ancestor node for any given node. So when you're calling f of v and something, there's kind of an additional constraint here that's pretty important, which is for v equals 1 up to n, this always equals n for any x. That's a weird way to write that. Whatever. The total number of descendants will always equal n. So maybe you mark what nodes you need. Because for any given f of something, this is going to turn into ultimately some sort of f of v and something, some sort of 2 to the x for any v. So then is there a way to aggregate these? I don't think so. No. Because you could have something that's like this, they all point here. One, two, three, four, five. And then your queries could be f of 5 and 1, f of 5 and 1, all the way down, right? And then there's not really any way to aggregate this because you would just have to like measure all of these a bunch of times, right? Shit, my phone died. All right, I think I'm gonna go in like 5 minutes. But if you had a way to do this, no, this would be solvable. This wouldn't be that bad, right? Because this is a power of 2. So it's really not that hard. And then if you even had f of 5 and 2, which is also a power of 2, so it would be fine, then that would mean there's a bunch of random stuff pointing to this. I don't want to write that all out. You have a bunch of random shit pointing to all of this. This is also, though, a power of 2, so it would really need to be f of 5 and 3, but whatever. We'll say f of 5 and 2. I feel like there's something there, right? Maybe not. Because you'd say, yeah, well, there's square root of n v such that like f of 5 of 1 equals v. Or f of 5 equals 1. But then this would really be n minus square root of n. So what am I saying here? For all nodes, the sum of all descendants of all nodes will always be n. It's actually not true. It will always be at most n. Because you could have something that's like, this is your graph. And what would this correspond to? 2, 3, 4, 4, I guess. And then you would say, well, for any f of v and greater than, I guess, 3, this would get you, this would be 1, and all of these would be 0. Because you would just be like, well, how many nodes are like, is this the great-great-great-grandparent of? The great-grandparent of? You'd say, well, goes off the edge, so none of them. So eventually you would get to a state where it's less than or equal to n, and it's greater than or equal to number of nodes in a cycle. Kind of important, I guess. Of course, the number of nodes in a cycle could just be n, but that's fine. So is it like a centroid decomposition? Because you can just immediately say, there's this many nodes in this tree, this far away from this thing. No. Maybe. That doesn't sound right. That might not be crazy. How does centroid decomp work? You add in the number of nodes above a certain distance away. No. That's for like weighted edges. I think that's not really relevant to this. That has to do with like a distance. No, maybe not. So what would that be? You would have some sort of node. They all lead to this. This leads to itself. No, that falls apart because you could just have a cycle. I don't think centroid decomposition means anything in that context. All right, I'm looking at the solution. I don't care. I've been thinking about this problem for like 2 weeks. Is this the right function composition? We're not going to bother you with another geometric story. Okay, this is the statement. We should first notice that this problem can be modeled as a graph theory problem. We define a graph in which there exists a directed edge from x to y if y equals a at x. Now we can make a few observations about this graph. Every connected component can be observed independently. Okay. Each node has exactly one outgoing edge. Okay. Queries ask for the number of x such that the mth ancestor is y. Okay. This graph has exactly one cycle per connected component. Great. We're given two cases. Either it doesn't belong to a cycle or it does. Okay. In this case, we actually have to find the number of descendants of y on depth m from y. We'll do this offline in the DFS traversal of the forest we get when we remove edges belonging to the cycle. At each point, we remember how many nodes exist on certain depth. When we first enter node the y, we remember how many nodes we have discovered so far on depth m from y. When we finish processing y, we can find out how many additional nodes we've discovered. So it's saying if y is not part of a cycle, you just DFS. You just say how many nodes at a given depth have we found. Okay. If it's part of a cycle, it's more complicated. Makes sense. We'll define an arbitrary node z on the cycle as the first node. Let the distance from y to z be t, and the length of the cycle be L. If we had a query with the distance m on y, we could now analyze the query for m plus t on node z. Wouldn't it be m minus t? We can easily answer the modified query by observing a tree we get when we remove the outgoing edge from z. M plus t. So the distance from y to z would be how far you have to travel to get to z. Okay. And then that doesn't sound right. We get the tree in which a node on the depth d is an answer to the query if d is greater than or equal to m plus t, or d is equal to m plus t mod L. All nodes which could be the answer for the modified query but not for the original one are ones which are on the distance m plus t from z, but the path from them to z doesn't pass through y. Jeez. I'm gonna have to think about that for a minute. So We got a cycle. Let the distance from y to z be the length, be t, and the length of the cycle is L. So t equals 4, L equals 5. Let's say we're looking for y and 8. Oops. Wow, so this basically had nothing to do with binary exponentiation. That's really interesting. If we had a query with the distance m on y, we could now analyze the query m plus t on node z. So we're saying f of z and 12? That sounds wrong. It must mean the distance backwards, which would make t be 1 and this be 9. So then we're saying, okay, pretend this doesn't exist. Now you have a tree. You treat it as such. You query z. You need to get rid of all of the nodes. Can easily answer the modified query by observing that a tree. By observing a tree we get when we remove the outgoing edge from z. We get the tree in which a node on depth d is an answer to the query if d is greater than or equal to m plus t. I forget, is that or and? And it's equal to m plus t mod L. So if I forget about the mod L for a minute, it's saying if the distance is exactly equal to m plus t. And there's only a single L, so I see how that's pretty easy to query. All nodes which could be the answer for the modified query, but not for the original one, are nodes which are a distance m plus t from z. All nodes which could be the answer for the modified query, but not for the original query. You can easily answer the modified query. So the original query is just distance m from y. Okay. So that handles this node. To answer for the modified query, but not the original one, are nodes which are on the distance m plus t from z, but the path from them to z doesn't pass through y. couldn't there be some distance 9 node that's a predecessor of Z? How does it, or a descendant of Z, how does it account for that? I guess you could say take an original query from Z. No, it's sloppy. All nodes which could be the answer for the modified query, but not for the original one, are nodes which are on the distance n plus t from Z, but the path from them to Z doesn't pass through Y. You remove the edges that belong to the cycle. Are nodes which are on the distance n plus t from Z, but the path from them to Z doesn't pass through Y. Alright, well, I'm out for now. Thanks for watching.